Bismillahirrahmanirrahim. This is exercise 2.7 Maths 12 differentiation, question number 6 and 7. Although the solution is available on several solution platforms on the internet, yet I am providing these two solutions here with a very different approach, and I consider this to be an easy approach than the one available on different solution platforms. So this is question number 6, exercise 2.7, math 12. If y is equal to e power x sin x, show that d2y over dx square minus 2dy by dx plus 2y equal to 0. Now the given is y is equal to e power x sin x. Move e power x to the left hand side. This is the primary difference between this solution and the other solutions. And in my view, this step makes this question very simple as compared to the others. So moving e power x to the left hand side will take it to the denominator y over e power x, which can be written as e power minus x y. So we will use this e power minus x y in our solution. E power minus x y is equal to sin x. Mark this as equation 1. Now differentiate both sides with respect to x. Using uv, the product rule for the differentiation here, this e power minus x is u, y is v. So u dv plus v du. So this is u dy by dx plus v du. V is y, so it is written as y. Now differentiation of e power minus x is minus e power minus x. And the right side sin x is equal to differentiation of sin x is cos x. Now e power minus x dy by dx minus this, I am solving it, this plus outside the bracket and this is minus, so I am simplifying it to minus e power minus xy equal to cos of x. Now differentiate again both sides with respect to x. Now this first term e power minus x dy by dx, again uv product rule. E power minus x d2y over dx square plus again the same thing minus e power minus x dy by dx. Now notice one thing here. This is e power minus xy, which now we will differentiate, and note that we have already done it here. This was again with us e power minus xy. We differentiated this and we found all this result. So this is the final solution of e power minus x, this solution here. So we write the whole thing e power minus x dy by dx minus e power minus x y. This is our differentiation of e power minus x y, and then the right hand side is minus sin x, because now it is cos x. The differentiation of cos x is minus sin x. Now e power minus x d2y over dx square minus, simplifying this, minus e power minus x dy by dx minus e power minus x dy by dx. These are the two like terms. We will collect them in the next step. And plus e power minus x y is equal to e power minus sin x. Now from equation 1, note that sin x is equal to e power minus x y. So we substitute sin x is equal to e power minus x y. So e power minus x d2y, we are collecting these two terms, minus 2 e power minus x dy by dx plus e power minus xy equal to minus e power minus xy. This comes from equation 1 here. Now note that e power minus x, e power minus x, e power minus x, e power minus x is in all these terms. So what we do is we divide both sides with e power minus x. So eliminating the d power minus x and writing this is as d2y over dx square minus 2 dy by dx plus y is equal to minus y. Moving this minus y on the right hand side to the left will make it d2y over dx square minus 2 dy by dx plus 2y equal to 0. That is your required proof, and it is proved here. Question number 7. Now it is y is equal to e power ax sine bx. Show that d2y over dx square minus 2a dy by dx plus a square plus b square bracket mein, and then it is y is equal to 0. Again, this question too has the same approach, exactly the same approach. If you want, you can pause this here and try this using the same approach by taking this e power minus x to the left hand side and then solving it. Most of you will be able to solve this whole question. However, if you are interested to see the solution, I will show you the solution here now. E power y is equal to e power ax sine bx. Move e power ax to left hand side. Again, I say it is y over e power ax is equal to, can be written as e power minus ax y. So we will prefer using this. E power minus ax y is equal to sine bx. Mark this as equation 1. Differentiate both sides with respect to x. This becomes e power minus ax dy by dx minus a, because now if we differentiate e power minus ax, the differentiation of the power minus ax will be minus a, and e power minus ax, you know that it remains the same, no difference, only this power has to be differentiated, the exponent with the x. And then it is, since it is the product rule, the y comes as it is. This is equal to b cos bx. So sine bx is equal to cos bx. This bx, differentiation of bx is equal to b. So this becomes b cos bx. Now differentiate again both sides with respect to x. Now this portion, e power minus ax dy by ds, again uv product rule. E power minus ax d2y over dx square minus a e power minus ax. Again differentiating this thing, e power minus ax, it is minus a e power minus ax dy by dx. Again, now it is the minus sign with a, and again this thing e power minus axy. Upper equation 1 mein we have already done this, and this was the whole solution. So I'll just copy this solution here on this. E power minus ax dy by dx minus a e power minus axy. Now this becomes equal to minus b square sine bx, because now this is cos bx. The differentiation of cos bx is minus sine bx. The bx will be given as only b, so this becomes b square. Now from equation 1, sine bx is equal to e power minus axy. So substituting this becomes the left hand side remains the same, and I write minus b square e power minus axy. Now simplifying the left hand side here, e power minus ax d2y over dx square minus a e power minus ax dy by dx. Multiplying this a inside here, this becomes minus a e power minus ax dy by dx plus this minus a, and this minus sign becomes plus a square e power minus axy. This is equal to minus b square e power minus ax. You note that every term involves e power minus ax, which I have colored for your easy identification here. So dividing both sides with e power minus ax eliminates all these e power minus ax. And collecting these two like sides, these are the two like terms here, d2y over dx square minus a dy by dx minus a dy by dx plus a square y is equal to minus b square y. Now I have collected these two terms and writing them again, d2y over dx square minus 2a dy by dx. Now I am moving this minus b square y to the left hand side. This becomes positive here. So this is equal to 0. Now taking y common here, this becomes a square plus b square. This is our required proof and it is proved too. So these are the two questions which I have done with this approach, that by taking e power ax to the other side, and this becomes an easy approach. If you like this solution, please let me know. Either click like this solution, so that I know that yes, this solution is of some use to the students, or write it in your comments. If you have any problem in any of the solutions in the book, please let me know. Give me the question number. I will see if there is a possible easier solution. I'll give you the easier solution. This is Archer's Easy Solution channel, meant to provide you the easiest possible solutions possible. Thank you very much.